To create a computer vision solution is never easy. You need to collect necessary hardware and software. You need to set up your camera stream, and you need to collect data, train the AI model, and set up AI pipelines. This is the reason why we created the CAM project. The idea of CAM project is to help you get started with edge computer vision solutions within just a few minutes. This is an open source project under Azure/CAM, and now the project is backed by Eclipse Symphony. To get started, you can go to our Get Started guide, where you can find install scripts. Just copy the link, go to your terminal, paste it in, and execute. So the script assumes you already have Azure Command Line Tool, AZ, installed, and you've already logged into your Azure subscription. And in this demo, I'm going to use an AKS cluster to host CAM portal. The first question the script asks you is whether you want to use Azure services, such as Computer Vision Service, Storage Account, and LT Hub. In this case, I'm going to say yes. And in later videos, we'll show you how you can use CAM without Azure subscription. And I'm going to say to use my current kubeconfig context, which is connected to my AKS cluster. The first thing to do is to create a storage account. I'm going to create a new one. Select the resource group, and I will say CAM store 3. And you can choose a location or use the default location. And now we need the custom vision service. I will create a new one as well. Resource group, CAM CV3. 3. And location. And now we need a service principal. You can create a new one or use an existing one. I'm going to create a new one. SP 2026. And we can define a custom role to assign access rights to Azure resources. If you don't use the custom role, we'll just assign the service principal to the contributor role. You can modify our script to use a file granular control if you need. So in this case, I'm just going to say no. And we deploy a Symphony agent that is used to take snapshots of your camera stream. We use FFmpeg, but by default, our image doesn't ship with FFmpeg installed. But you can use community image, have the tool installed. So I'm going to select tool in this case. And to expose the CAN service, you can choose to use the Nginx ingress controller, or you can set up the service as a load balancer service, or you can use a traffic ingress controller. This is mostly for the case of K3s, where you have the traffic controller by default. In this case, I'm just going to use the Nginx controller. And here you have the option to send some telemetries back to Microsoft. Here I'm just going to say no. And review your choices and say yes. And now the service principal has been created. We only display the credential once, so make sure you copy this data because later on, if you run the installer again, you will need to enter your credential. So I'm going to copy this. Okay, I've saved that away. I'll press enter to continue. Okay, after a few minutes, your CAM portal should be ready to go. Just Control-click on the link and open your browser. And here's my CAM portal ready to use. Now let's deploy our computer vision solution. First, we need to define a compute device. We don't require you to have any special hardware. Actually, we allow you to use your current Kubernetes cluster as the device. So in this case, I'm just saying I'm going to add a Kubernetes device. I just give the name, let's say KAS. And I can say there's no special hardware. I just use CPU acceleration. I just create the machine. So now my Kubernetes cluster is registered as a Symphony target where I can deploy my payload to. Next, I will need a camera. I will create a camera. I will say people camera. Because I'm deploying to AKS, I will need a public RTSP stream. In the moment, I will show you how you can easily set up a few test streams. But in this case, I'm just going to enter the address first. RTSP 554 media people waiting. This is one of the test streams. And optionally, you can have user ID and password. But here I'm just selecting, I'm going to associate the camera to my Kubernetes cluster. And location is where you want to tag your camera to show where the camera is. You can use anything. Here I'm just say this is my store. I will create the camera. Okay, now the camera is created, and you can click on the view link just to check if you actually get the feed. So this is from my test stream. It should show up the preview of the video. Okay, it seems the camera is in place. Go back here. And now I'm going to ready to create or use an existing model. So by default, we have a model zoo that gives you a few models for like a people detection or car detection, but you can create your own custom models. We will show you this in another video. So once you have the model, you can start to create your AI pipeline, which is called AI skill. So I'm going to create a skill called people detection. And again, I just use CPU. Next. Now I have this graphic UI that I can drag and drop my pipeline. I'm going to create a really simple one. Basically, after the camera input, I'm going to run a machine learning model, link to it. And here you can see you can select from the default model we included in the CAN portal. I'm going to use object detection. I'm going to do person detection, which detects a person. Done. Then I'm going to add a filter because I only want to get detections with high enough confidence. I'm going to say if the person tag has confidence larger than 70%, then I will continue the pipe. And in this case, I'm just going to export the video to my storage account. Just link it up. And you can set a prefix for your storage account file name. I'll just say people. And you can select the duration. I'll say 10 seconds. And I want to display the bounding boxes. So done. Now my pipeline is ready. I just will and create. Okay. Now it's the exciting moment. We are ready to deploy this solution. I'm going to do the deploy screen. I'm going to say a new deployment. I'll say deploy 1. I will choose a computer device. I'm going to choose camera. And going next. And I will associate AI skill to the camera. Here's the people detection AI skill I just created. I say add. Then I will say, actually I don't need to say next. I just deploy this. So now we are actually deploying this end-to-end computer vision pipeline for you. If you click into this deployment, click into the AI skill, select the camera, and you can see a preview of the camera stream. In this version, we have some problem displaying the camera status. but never mind about that. It should be working fine. And if you have IoT Hub configured, you should see the IoT Hub messages about the detection. But if you have your storage account, you should start to see the video snippet got uploaded with bounding boxes. If you click on this, you can see indeed we have our computer vision solution working with people detection just under a few minutes. And before we stop, I will show you how to set up the camera streams. Actually, in our repository, if you go to our tutorial, there's a section about how you can set up a Docker container and run a sample RTSP server with a few predefined video streams. Then you can use these as the testing environment so that you can run everything end-to-end without any hardware. I hope you enjoyed this. We really wish we can use Ken to help you to get started with the computer vision project. And in the future videos, we will show you how you can customize the AI model to do your own detections. Like if you want to detect oranges, if you want to detect cats and dogs, we will show you how to do that. Until the next time, thank you very much.